Okay. All right, so 31 said, well, first of all, from this grouping, we need all the 3-digit numbers. So this is going to be 100 through 999. So I need to get rid of 1 through 99 is what we are getting rid of. So our total number of numbers is going to be 999 minus 99, so that's 900 numbers. Chris? What? There's more than 99 what numbers? I'm not talking about odd numbers. I'm talking about I need to figure out our total number of numbers that we have that are 3-digit numbers. I need to know how many there are. I need a total number of how many I have here. Chris? So if I'm doing the probability of any of these, it's the number favorable over the number possible, correct? Yeah. Okay. Our number possible is how many total number of 3-digit numbers there are. Isn't that? Okay. So for us to figure out how many 3-digit numbers I actually have, it's 1 through 99 is like 1 through 99 are all my numbers, including 3-digit numbers. So I need to get rid of the single digit and the double digit numbers. So I need to get rid of 1 through 99. That's 99 numbers, right? Okay, so our total number, this is our total possible. That is going to be our denominator for all of those, 27 through 31. Does that make sense? Okay, so sit up to your desk and pay attention to what we're doing. All right, so for number 31, it said I want the probability of the number is a multiple of 30. So, any one of these, I'm going to say this to you. I hate to be the bearer of bad news, but you might actually have to do some work on this. Put your hand down off your face and listen to what I'm doing. Get your pen in your hand. You might actually have to list out the numbers. Okay, so if I list out these numbers, I have 100, I have 101, 102, 103, 104, 5, 106, 107, 108, 109, and I'm just going to start with 110 down here. All right, so I have 110, 120, 130, 140, 150, 160. All right, so I could list all these out and figure out which one of them are divisible by 30. All right, so we want to know which ones of them are multiples of 30. So what we're actually looking for is how many are divisible by 30. All right, well, if I do this, let me erase this for a second. What's my first number once I list all these out that's going to be divisible by 30? What's my first one? So this is going to be 111, this is 112, this is 113, this is 114. Which one of these is going to be my first one that's going to be divisible by 30? Ashton? 120, I do agree with you, is going to be divisible by 30. Isn't there one before that that's going to be divisible by 30? What about 150? Is 15 divisible by 30? 15 is divisible by 3, isn't it? All right, so let's check and see. So I'm thinking about my numbers that are divisible by 3, because that's going to help me. So 150 divided by 30, that's going to give me a 5. So 150, I'm set. 150. Yeah. It has to end in a 0. So 150 is going to be divisible. 120. What's my next one that's going to be divisible by 30? So this is where we start to see a pattern going on. All right. So what's my next one that's going to be divisible by 30? So this is 30 times 4. This is 30 times 5. What's my next one that's going to be divisible by 30? Nick? 180, because that's 30 times 6. What's my next one that's going to be divisible by 30? Come on, you guys, I want you thinking. This is 120. This is 4 times 30. This is 5 times 30. This is 6 times 30. What's my next one that's going to be divisible by 30? Matthew? 210, because that's 7 times 30. What's my next one that's going to be divisible by 30? Victoria? 240. What's my next one? Can you guys see the pattern going on here? All right, so we need to list all these. Sam, what's my next one? 70. What's my next one from there? Come on, you guys. Ava, what's my next one? So this is 9 times 30. What's 10 times 30? 300. What's my next one up for that? Or just add 30 each time. What's my next one for that? Jacob? 330. What's my next one? Charlotte? 360. What's my next one? Isabella? 390. And we would keep going from there. So there is a little bit of work that goes with some of these. All right, does that help you? All right, what else can I do for you guys? Yes. It's not. The answer is 1 over 30. 32 is 4 9s. All right, what else can I do for you guys? You guys pretty good with this stuff? All right, get your notes out. Let's talk about experimental probability. So we are still in 4.5, so 4.5 continued. And we're going to talk about experimental probability. Experimental probability, this is when it uses actual data. So things like surveys. I could survey this class and get information. It could be experimental trials. Like medicine trials, drug trials. All right, any drug that you have taken has gone through an experimental trial. A clinical trial is a lot of times what they're called. How many of you guys have ever heard of clinical trials? All right, so in clinical trials, it's a medicine that you're giving to a group of people that has an ailment. And you're giving some of them the drug and some of them not the drug. It's called a placebo. And you're looking to see and compare the results of what happens when those people are on the placebo or on the medicine. All right, and we take that data and we look to see what is the probability. It's always going to be in percent form for experimental probability. What is the proportion or the percentage of people where the positive effect that you wanted happened? All right. So we have surveys, we have experimental trials, we have one of the things we have is quality control. I'm going to do one of those today. We have quality control. So every single thing you use, that you order, that people make in mass, has quality control. So how many of you guys have mechanical pencils? All right. So the people that make the mechanical pencils, think about when they're made, they're all thrown in a bin. So there might be 1,000 or 2,000 or 10,000 thrown in a bin. It is somebody's job to go through and gather a sample set. If there's maybe 10,000 in a bin, they might grab 500 of them. Just randomly grab 500. And they might check through to see if they all work. They're going to go in there, put pencil lead in, and they're going to make sure they all work. And they're going to take note and they're going to take data on how many there were that did work. And they would come up with a percentage of those pencils in the sample set that worked. Okay? We use that to figure out how many we could predict in the whole 10,000 then that would work. All right, and so when you're making something, some of them aren't going to work. So there's an acceptable percentage of a product that if it doesn't work, they're still okay with the design. Okay, that's just kind of how creating things works. All right, so experimental probability is when we're dealing with actual data. All right, the formula is still the same. So it's our probability. So the probability P of an event is equal to the number of favorable over the number possible. But I want to be more specific with what those two things mean. The number of favorable and experimental probability. This is the number of results we want. The number of pencils that were not defective. The number of patients that the medicine cured, whatever it is it was supposed to cure. All right, our number possible, these are the total things analyzed. If it's people, it's the total number of people in the trial. If we're checking for defects of pencils, it's a total number of pencils that we check to see if they were defective or not. Okay, so that's what favorable and possible mean with regards to experimental probability. So let's do a problem like this. All right, so we are going to do example number 3 from page 213. All right, who needs to see what's up there? Okay, so let me show you this example. I want you guys to write this information down, and we're going to talk about it. Oh, one of the things I want to say about experimental probability. The answer always in percent form. So the answer is always going to be in percent form. Write that down, please. The answer is always going to be in percent form. Where in theoretical probability, we usually leave it as a fraction. In experimental probability, we always do it as a percentage because it makes more sense. 85% of the people had a positive effect from this medicine. That means something. All right, that has a you can understand that much better than 850 people out of 700 or out of 932. That doesn't really mean much to you. So percentage. Okay. I want you to write this information down, and then we're going to talk about it. Get going, please. All right, so we need to find the probability that a skateboard is not going to have a defect. And if you notice, 1,000 skateboards were inspected. All right, so we're going to start with our formula. Probability, I'm going to unfreeze this so you can see what I've written here. So I've written my given down. After receiving complaints, a skateboard manufacturer inspects 1,000 skateboards. So there are the total number of skateboards inspected. 992 of them did not have defects. We want to find the probability that a board's not going to have defects. So probability, so P, and I'm going to say no defect, equals. What's the formula for probability? What's the formula for probability, Jacob? Well, I'm going to say P of no defects. Excellent. In this situation, what is my number of favorable? Chris? Yeah, because 992 of them had no defect. All right, what does my number of possible represent here, Peter? That's at 1,000. That's the total number of boards that were inspected. All right, so now you're changing that into a decimal and then into a percentage, please. You guys all have your calculators. How do I turn a decimal into a percent once I found it? Nick? You multiply it by 100. So what is the probability out of those 1,000 skateboards that you're not going to have a defect in them? Serena? No. Did you type in 1,000 divided by 992, or did you type in 992 divided by 1,000? Okay, is that, put your hands down. Serena, look at this fraction. It's 992 over 1,000. So this says 992 divided by 1,000. So what should it be? Excellent. So 99.2%. Remember, it's always your numerator divided by your denominator. Questions on that? Okay. So, I want to talk about how we use this. All right? So let's do another problem similar to that. And now we're going to use probability. So using probability to predict outcomes. All right, so I'm going to set up a very similar situation. All right, so let's say a skateboard manufacturer has 8,976 skateboards in his warehouse. Okay, so like I said earlier, when you have quality control people, they're not going to go to every single one of those skateboards and check every single one of them. They're going to randomly take a certain amount and check them. All right, that's called a sample set. All right, so let's talk a little bit about that. So there are 8,976 skateboards in a warehouse. All right, a quality control person gathers a sample of those boards of, let's say, 200 skateboards. So they just grabbed 200 of them randomly. Of the 200 boards, 188 had no defects. All right, so this grouping here, this 200, that is our sample set. So the quality control people grabbed a sample set, a smaller amount of the overall boards, and we are testing those. Yes. Go. All right. So using the sample set, find the probability a skateboard will not be defective. All of you do that right now. So you're using the sample set. So right now you don't care about that total number of skateboards of that 8,976. We're just dealing with the sample set. You're always changing this into percentage. So at the very end, you're just going to change it into a percent. I don't put multiplied by 100 on the formula because we use that formula whether we want it as a percent, a fraction, or a decimal. But if you know you want it as a percent at the end, I just say times 100 because it's not always going to be on that formula. Does that make sense? Yeah. So you're all doing this. So you all should be writing probability no defect equals number of fave over the number possible, and then you're putting your numbers in. Remember, when you're done, turn it into a percentage, please. So somebody put my numbers into this. All right, Peter, go ahead. Okay. So 94% of them had no defects. How many of you guys are cool with that? Okay. So now this is the new thing. All right. So using this probability, predict how many of all the skateboards in the warehouse, predict how many of all the skateboards in the warehouse will not have a defect. So this is the new thing. We want to predict using that probability. All right, this relies very heavily on you setting up that equation and writing that formula very specifically. All right, so I'm going to go ahead and just do this on the other page. What is my formula to find? You're not zooming ahead. I need you with me. Someone tell me what the formula is to find the probability of no defect. Chris? No. Just give me the formula. So I want you to tell me the formula. Probability of no defect equals. So number of fave over number possible. Okay. So, Chris, what did we find was our probability from that problem from the first part of this? So this is our 94% equals, because that was our probability that we found. All right. How many total possible are in the warehouse, Chris? No, that was the sample set. Excellent. So when we're predicting, we need to use total number in the warehouse. We used the sample set to find that probability. Now we want to know what's in the warehouse. Chris, what don't I know? I don't know my number of favorable. I'm just going to give that my x because that's what we're looking for. So someone tell me, for me to use a percentage in math, what do I have to turn it into? Matthew? Or a fraction. So since we have our calculators, just turn into a decimal. Matthew, what is 94% as a decimal? So I have 0.94 is equal to x divided by 8,976. I just need to solve this. What am I going to do to solve this? Matthew? What? No. Why am I dividing? This says x divided by 8,976. How do I undo the division of 8,976? Yeah, I'm just going to multiply both sides by 8,976. I'm just going to multiply both sides by that denominator. So my denominators cancel out, and now I'm going to go ahead and do 0.94 times 8,976. So I got x equals 8,437.4, but I can't have 0.4 of a skateboard. So this is approximate, so I'm going to say I predict 8,437 skateboards will not be defective. All right, so the key to this is starting with that formula, both when you're finding the probability of something and when you're using the probability. When you're finding the probability, you know the number of favorable, you know the number possible. When you're using the probability, you know the number of possible, you know the probability, you just don't know the number of favorable. There is your unknown. Are you guys cool with this? Okie dokie. You guys are good to go.